Workbook 16. We're going to jump to question 10. Move up from there. Alright, in circle C, a circumscribed angle XYZ and the central angle ZCX intercept the arc XZ. If the measure of angle of the arc XPZ, so if this angle on this arc is 271 degrees, and the measure of angle XYZ, so this angle is 4x plus 15, then x equals blank. Okay, well then I am thinking, well, I know that central angles are going to be the same as the arc, the measure of the arc angle. So since we know that this from XPZ is 271, and we know there's 360 degrees in a entire triangle, the measure of XZ, that arc, is going to equal 360, the entire circle, minus 271. So then let's go here, 360 minus 271. Whoops, I did 660. 360 minus 271. That's going to give us 89. Okay, and then from that, I know that in a quadrilateral, well, I know that the angle C and angle XYZ are going to be supplementary, so they're going to add up to 180 degrees. And since we know that this angle is 89 degrees, sorry, I should say that angle is 89 degrees right there. Okay, so then we know that angle XCZ plus angle XYZ is going to equal 180. So that's one of the rules. So then angle XCZ is 89 degrees plus the angle of XYZ is 4x plus 15, and that equals 180 degrees. And now it's asking us to find the value of x. So I'm going to combine all of my like terms first and then solve. So what's 89 plus 15? Well, 89 plus 10 is 99, and 99 plus 5 more is going to be 104 plus 4x. That one didn't have a like term, and that equals 180. So I got 104 plus by adding 89 and 15. Alright, so now I want to have x be by itself, so I'm going to subtract the 104 from both sides. Again, if there's not a negative sign in front of the number, it's assumed to be positive. So that's how I knew to subtract it. So 104 minus 104 is 0, plus 4x. That equals 180 minus 104 is going to give us 76. And then 0 plus 4x is 4x equals 76. And then 4 is multiplying by x, so we're going to divide by 4. 4 divided by 4 is 1x equals 76 divided by 4 is 19. So x is equal to 19. Again, we have that ninja 1 there. So x is going to equal 19. Submit for grading. Great job. Alright, so now we're going to move on to question 9. In circle C, a circumscribed angle QPO and central angle QCO intercept arc QO. If the measure of angle P is 6x plus 6, what is the value of x? Okay, this is very similar to what we just did. So this angle is 6x plus 6. And we know that the central angle and its opposite or circumscribed angle adds up to 180. So we have 126 plus, alright, I'll write this all the way out. We have that angle QCO plus angle QPO is going to equal 180 degrees. So then we know that the angle QCO is 6x plus 6 plus the angle QPO is 126 degrees, and that's going to equal 180. Alright, well, I'm going to combine like terms. 6 and 126, that's going to give us 132 equals 180. So then we're solving for x, so now I'm going to be moving my constants over, so I've got to subtract 132 minus 132. So then we have 6, x is going to plus 0 is going to equal 180 minus 132. Well, 180 minus 130 is going to be 50. Minus 2 more is going to leave us with 48. So then 6x plus 0 is 6x. That equals 48. 6 is multiplying by x, 2x, so we're going to divide by 6. Divide by 6. 6 divided by 6 is 1x. And 48 divided by 6 is 8. So we have x is equal to the 8 right there. Great job. Alright, so it's really important to remember the rules that they connect to. So in circle C, a circumscribed angle DAB and central angle BCD intercept arc DB. Given that central angle BCD and circumscribed angle DAB intercept arc DB, Brittany must prove that these opposite angles are supplementary. That means that they add up to 180 degrees. She writes the following 2-column proof, but she is missing a few steps. Read her proof carefully, then answer the question. Okay, angle DCB and angle DAB intercept minor arc DB. That's given. Blank. 1. Rays or sides of circumscribed angles are tangent to the circle. Okay, so it's talking about rays or sides of a circumscribed angle are tangent to the circle. So that means they are talking about this angle, this side, and that side. Okay, and then so blank 1, AD, the the one side, and AB is the other side, are tangent to the circle or blank one, CB and CB are tangent. Well, our circumscribed point is A, so that is our blank for blank one. Then we know that AD is perpendicular to CD, so AD is, whoa, that shifted. AD is perpendicular to CD, and AB is perpendicular to CB and blank 2. The reason why we know that our tangent lines are perpendicular to radii at the point of tangency. That was in one of our earlier lessons. So blank 2, tangent segments are perpendicular to the radius at the point of tangency. That is correct. Then that means that angle ADC, I keep shifting, angle ADC is, and angle ABC are right angles. Yes, that's the definition of perpendicular segments. So then they're talking about, in the next step, measure of angle ADC and measure of angle ABC equal 90 degrees. Yes, that's the definition of our right angle. So then they're saying measure of angle ADC plus the measure of angle ABC plus the measure of angle DCB, so this angle, plus the measure of angle BAD, this angle, is equal to 360 degrees. So she's saying that all of these angles right here add up to 360 degrees. Well, blank 3, why is it? The sum of angles in a quadrilateral is 360 degrees, or the measure of an entire circle is 360 degrees. Okay, well, let's look. Do I have a circle that's enclosed, or do I have a quadrilateral? And we have a quadrilateral. So there's our quadrilateral, and then it goes on to simplify this. She substituted the measure of angle ADC, which was 90, and the measure of angle ABC, which was 90, which is 180. And then she subtracted 180 from 360, which left her the 180 here. So that's how she moved from step 7 to step 8. And the definition of supplementary angles is that they add up to 180 degrees. So then the rest of her proof was good. And great job. Okay, so now question 7. Quadrilateral HIJK is inscribed in a circle C if the measure of angle H is 115 degrees and the measure of arc IHK is 4x plus 22. What is the value of x? Okay, well, we know that if I looked at the angle, the inscribed angle that cuts this arc off, IHK arc, we know that angle J is going to equal 1/2 of the measure of IHK. We know that, and we also know that opposite angles, so angle H and angle J in quadrilaterals are going to be supplementary. So we know that angle H plus angle J is going to equal 180 degrees. So we need to find out what is the measure of angle J. So let's use our substitution. So measure of angle H is 115 degrees. We don't know what the measure of angle J is, but we know added together H and J equal 180. So I'm going to subtract it from 115, and that's going to be 180 minus 110 would be 170, minus 5 more would be 65. And 115 minus 115 is 0. So we have 0 plus j equals 65. 0 plus j is just j. So the measure of angle J is 65 degrees. And now we can jump up here and use this one. We know that the angle of J is going to equal 1/2 of the arc that it intersects. So we know it's going to equal 1/2 of the arc IHK. So we know that angle J is 65, and that's going to equal 1/2 of, we have the measure of IHK is 4x plus 22. Now we can solve for x. So then I'm going to come up here in just a second. We're going to distribute this 1/2. So what is 4x times 1/2? And that is going to be 2x. And what is 1/2 times 22? That's 11. So we have 65 is equal to 2x plus 11. Now I want to solve for x, so I'm going to move my 11 to the other side by subtracting it since it was added. So 65 minus 11 is going to leave us 54 equals 2x, and 11 minus 11 is 0. So then we have 54 equals 2x, because 2x plus 0 is just 2x. So now 2 is multiplying to x, so then we're going to divide by 2. Divide by 2. 54 divided by 2 is going to leave us with 27. And that's going to equal 2 divided by 2 is a 1x. So therefore our x is equal to 27. Remember, it's that ninja 1. So our x is equal to 27. We're going to come down here and check it. Submit for grading. Great job. Alright. Okay, question 6. Quadrilateral JKLM is inscribed in circle C. Given that quadrilateral JKLM is inscribed in circle C, Aaliyah must prove that its opposite angles are supplementary. She writes the following 2-column proof, but she is missing a few steps. Read your proof carefully and then answer the question. Okay, well, quadrilateral JKLM is inscribed in circle C. That's given. Angle J intercepts arc MLK. That is correct. And angle L intercepts the measure of arc MJK. That is given. So then the measure of angle J is equal to 1/2 the measure of the arc MLK, and the measure of angle L is equal to 1/2 the measure of MJK. Blank 1. Well, blank 1 is it the base angle theorem, where the angles of the triangle, or is it the inscribed angle theorem? And that is the inscribed angle theorem. it says that the inscribed angle, so the angle J, is 1/2 of the measure of the arc that it cuts off. So now she has 2 times m equals 2 times the measure of angle J is equal to the measure of the arc, and 2 times the measure of arc, 2 times the angle of L is equal to the measure of the arc length MJK. Multiplication property of equality. She's simplifying, and then measure arc MLK. Let's see, arc MLK and MJK are adjacent arcs. Yes, because they're right next to each other. That's the definition of adjacent arcs. And then the measure of the arc MLK and MJK are a pair of corresponding minor and major arcs. Definition of minor and major. Then the measure of MLK plus the measure of arc MJK equals 360. The measure of a minor arc and its corresponding major arc have the sum of 360 degrees. That is correct because they go the entire distance around a circle. So then 2 times the measure of angle J plus 2 times the measure of angle L is equal to 360. Blank 2. How did they jump to this? Well, if you look step 4 says that 2 times the measure of angle J is equal to the measure of the arc MLK. Well, we had the arc of MLK right there, and so they substituted it in. They just used their previous knowledge to substitute it. So it's the substitution property of equality. Blank 3, the division property of equality. So they're looking for an equation. So does blank 3, the measure of MLK plus the measure of, it should have the measure of angle J and the measure of angle L. And we're going to divide it by 2. So we have the measure of angle J plus measure of angle L is equal to 180 degrees. And then that means that they're supplementary. So let's check our reasonings. Great job. Alright. So if you haven't already written down your definition of supplementary angles or the inscribed arc theorem, I would recommend writing that down. Okay, so now we have triangle EFG is inscribed in circle C, and segment EF is the diameter of circle C. If the radius of a circle is 2.5 feet and GF is 4 feet, then the length of EG is blank feet. Enter your answer as the number that correctly fills in the blank. Okay, well, what did they give us? They gave us that EF is this diameter, and they said that the radius, so half of it, is 2.5. So if I double that, I'll get the whole distance of EF, which would be 5. And then they tell us that GF is 4 feet, and they want us to find EG. Well, how can we do that? There's a few things that we know. We know that in an inscribed angle that cuts off the diameter or has the endpoints at the diameter, then that angle is going to be 90 degrees. So angle G is 90 degrees, and since angle G is 90 degrees, we have a right triangle now, and we can use the Pythagorean theorem of a squared plus b squared is equal to c squared. Now our hypotenuse is going to be equal to the opposite. The hypotenuse is always across from our 90-degree angle. So our hypotenuse is 5 squared. That's going to equal a side length. So GF is a side length, so that's 4 squared. And EG is the other side length, which we are trying to find, and that distance is squared. So let's solve for EG. So EG squared, or the distance of EG, plus 4 squared is 16, 5 squared is 25, and now I want to isolate EG. So I'm going to subtract 16 from both sides, and we're left with EG squared. 16 minus 16 is 0. That's going to equal, well, 25 minus 16 is 9. So EG squared plus 0 is EG squared. And that's equal to 9. But we're looking just for EG, not EG squared. So how do I undo, or what's the inverse of a square? And it's the square root. So then we're going to have the square root of EG squared is just EG equals the square root of 9 is 3. So our distance for EG is 3. So let's check our answers. Make sure we did it correct. Great job. Alright, there's your questions for workbook 16.